Okay, so this is going to be a set of notes on box plots and outliers. In order to understand a box plot, we have to first understand what's called a 5-number summary. The 5-number summary involves 5 specific quantities: the minimum of a set, the first quartile, the second quartile, which we're also calling the median of the set, the third quartile, and the set's maximum. Okay, so what a box plot does is it represents these 5 things. It builds a plot that has a box in the middle, and then that box has a line here. And the lower fence of the box plot is the minimum. This is Q1, this is Q2, or the median. This one is Q3, and this one is the maximum of that set, and this gets graphed over a set of numbers, right? So whatever these values happen to be. So we're actually going to use the calculator to create a box plot. So let me switch over to the calculator here and we'll move forward. Okay, so if you look in the notes for this section, there's a data set provided in there. I'm going to use that data set to create first our 5-number summary and then our box plot using the calculator. So I'm going to go ahead and go to Stat and Edit List 1, and I'm going to put in there that data set. So bear with me a second here. So we have 22, 22, 26, 24, 23, 27, 25, 20, 24, 26, 25, 25, 19, 24, 20, 22, 24, 25, 25, 20, 23, 30, 26, 20, 25, 28, 19, 26, 26, 23, 25, 23, 23, 23, 22, 26, 27, 23, 28, 24. Okay, so there's the whole data set. Great. So we have that all in there. We want to first find the 5-number summary, and that's pretty simple to find. You do stat, calculate the one variable statistics for L1. So we're going to leave the frequency list empty and hit calculate. And if I scroll down, there's the 5-number summary. The minimum of X is 19. Q1 is 22.5, Q2 or the median is 24, Q3 is 26, and the max is 30. So if I want the calculator to generate a box plot for this, right, I'm going to actually go to second y equals, brings up the stat plot. I'm going to turn the first stat plot on. I'm going to choose the box plot option. Now, the calculator has 2 box plot options. This is a modified box plot and a standard box plot. We're going to get into that one later on, but we're going to use this one right now. So there's the standard box plot. So let's just do this for list 1 with a frequency of 1. And I hit zoom, and I'm going to choose option number 9, which is the stat option. So I'm going to pick zoom stat. And there's my box plot. Pretty simple, right? So if I hit the trace function here, I hit trace, and I use my arrow keys, right, it will actually show me, okay, down there at the minimum, the bottom is the minimum at 19, Q1 at 22.5, the median at 24, Q3 at 26, and the maximum at 30. Okay, so there you have a box plot. Okay, so what we're going to do is we're going to first then define what an outlier is, and then we're going to modify our example here a little bit to have an outlier, and we'll go from there. Okay, so let's pause. Okay, so in order to be able to talk about an outlier, we have to first be able to determine what is called the IQR, or interquartile range. Okay, the IQR is just the distance between Q3 and Q1. It's how far apart are these values. So like in our example, Q3 was 26, Q1 was 22.5. So the IQR in our example would be 26 minus 22.5, or 3.5. Okay, what an outlier is, any value that is less than Q1 minus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR. Okay, so in our example here, Q1 was 22.5 minus 1.5 times the IQR, which is 3.5. And if you work the math on that, you're going to get 17.25. Okay, so this is the lower bound that we have to be below to be an outlier. And then we take Q3, which was 26, minus 1.5 times 3.5. And if you work the math on that, you're going to get 31.25. So a value that is below 17.25 or above 31.25 would be an outlier. Now, if you look at our data set, all the values, the lowest value in our data set is 19. That's the minimum. We found that the maximum for that data set was 30. So none of the values in this are outliers. These are all well between 17.25 and below 31.25, right? So above 17.25 and above 31.25. So what we're going to do now is we're going to see well, what happens if I throw some outliers in here, right? So we're going to throw two values that are going to just definitely be outliers. We're going to add in a value 1 and add in a value 60. Okay, and we'll see what this does to our math and how that looks when we look at this in the calculator. Okay, so let's bring up the calculator. Okay, so before we get into our experiment by adding in our outliers, let's just try something here. Let's turn the stat plot and change it from the standard stat plot to the modified one. Sorry about that. That's a little weird. Computers do weird things sometimes. So when I change it to the modified one, it's going to add a little thing about check marks here at the bottom. We're going to leave that alone for the time being. We're just going to hit zoom 9. And lo and behold, it didn't change my stat plot at all. And the reason why it didn't change is because my data set has no outliers. Now what we're going to do is we're going to go in stat and edit, right? And down here at the bottom, we're going to add two numbers. So all the way to the bottom. Oop. There we go. We're going to add 1, which is going to be an outlier. And we're going to add 60, which is going to be an outlier. So 1's going to be way lower than this data set, and 60 is going to be way above it. Now, note, when I add those values, that's going to change my 5-number summary. So if I did stat calc 1 variable statistics, calculate, and I look at the 5-number summary that's down there at the bottom, my minimum is now 1, my maximum is 60. Q1 has definitely changed. It used to be 22.5, now it's down 22. The median and Q3 don't seem to have been affected as much. But note, my IQR has moved from 3.5 to, let's see, 26 minus 22. 26 minus 22, oops, minus 22 is 4. So my IQR is now 4, right? So anything 22 minus 1.5 times 4, right? So that's Q1 minus 1.5 times 4 is 16, right? And 26 plus 1.5 times 4, so that's Q3 plus 1.5 times 4 is 32. So anything below 16 or above 32 is going to be an outlier, right? All right, so this definitely means that the values 1 and 60 are outliers. So if I graph like the standard box plot here, that doesn't show that. It just makes everything look smushed in the middle. Like there's my standard box plot. I hit zoom 9, and now because I have these outliers, I hit trace. My minimum is now all the way down here at 1. My Q1 is up at 22. Median's at 24. Q3 is at 26. The maximum is that outlier way out there at 60. But I want my box plot to show that these are outliers. So what I do is I go second stat plot. Right? Turn this on. And I choose this modified box plot. So that option there, and it says, well, what's this mark down here? Well, right now I'm going to leave it at that square. And if I zoom 9 again, okay, what it does is it kind of changes the game a little bit here. So I'm going to hit trace, and let's see what these numbers are. All right, this is 1, that's my minimum, right? This is 19, that's my minimum if I threw out the outliers. Okay, see that? I'm back to the minimum without the outlier. Q1 is back at 22. Q2 is at 24. Q3 is at 26. This would be my maximum without the outliers, would be 30. And then that dot out there is the outlier, 60. So it removes the outliers from the dot plots, or the box plot, puts them out as dots out on the edge there. So you can see clearly that they're outliers, but that this piece here would be the set without the outliers. All right, so there you go. You can play around with these, but they're pretty easy plots that give you a lot of information, particularly if you have outliers in the set and what the set would look like without them. All right, thank you.